Okay, this is part 2 continued. We're trying to figure out whether we have a constant function, a direct variation function, or a partial variation function, or other. Okay. All right, so what I'm doing is I'm looking at the rate of changes, and so I'm looking at the rate of changes between the point 812 and 1012, and so delta y is 12 take away 12, which is 0 right away. That should, you don't have to do anything further. You're going to get 0 over whatever is 0, unless it's 0 on the bottom, which would just be weird. Okay, so we have a 0 rate of change, okay, which means like right away if you have no rate of change, it's going to be a constant function. Well, not right yet, because we want to determine that the rate of change is staying 0, right? So I'm going to go and look at the other point as well. All right, I could also do the first point and the last point. Like, I mean, I could do, there are 3 different sets of points that I could use. I'm just doing 2 though. So if I did 12 take away 12 over 24 take away 10, it's still going to give me 0 over 14, which is still 0. Okay, so that means the rate of change is 0. So that means we're talking about a constant function. Okay, and in this case, the y value is always 12, no matter what the x value is. So y equals 12, and that's a constant function. Okay, we get a nice horizontal line passing through the y-axis at 12. All right, for E, rate of change is going to be, I'm going to look at these 2 points. So delta y is 5 take away 14, which is going to be negative 8, and then 5 take away 2, which is, sorry, not negative 8, negative 9, and then 5 take away 2, which is going to be 3. Okay, so negative 9 over 3 is negative 3. So we have a negative rate of change. Okay, so it's a decreasing function. All right, at least it's starting as a decreasing function. Let's see. Then I'm going to look at these 2 points. So my delta y over delta x is 2 take away 5, which is negative 3, and then 6 take away 5, which is 1. So that gives us negative 3 over 1, which is, once again, negative 3. So our slope has remained constant. So that means that either we have a direct variation or a partial variation. We just have to determine whether it passes through the origin or not. Okay, and so if I just take any one of these points and then use another point like 0, 0, use the origin as the other point, and then figure out the slope, you should get negative 3. Okay, but for example, if I take the 14 over 2, the 14, sorry, and the 2, so the 2 and the 14, the delta y is going to be 14 take away 0, which is 14, and 2 take away 0, which is 2, and that's why I was saying 14 over 2. 14 divided by 2 is 7. We get a slope of 7, okay, which doesn't work. We're looking for a slope of negative 3. All right, this means it does not go through the origin. Okay, but we could also say, okay, constant rate of change, so y equals ax plus b. The a is negative 3, okay, and then I'm going to solve for b. Okay, and then, so I'm just going to use a point. I'm going to take the first one. This one would also work. They would all work, by the way. That works too. So if x is 2 and y is 14, I have 14 is equal to 3 times 2, which is 6. I'm going to subtract 6 from both sides, and that gives me b is 8. So I get this. So we know that's a partial variation, okay, because the line is passing through the y-axis at 8. Okay, so we get a nice equation like this: y equals negative 3x plus 8, and that's partial variation. Okay, f. Let's do that again. So minus 2 minus 2. Oh, look at this. The y's are staying the same. So we're probably going to, well, not probably, we are definitely going to get a 0 variation. Okay, so we're going to get a constant function. So I get negative 2, take away negative 2 is 0 over whatever is still 0. Over here, if I do these 2 points, I have negative 2 take away negative 2 over 12 take away 6, which is 0 over 6, which is still 0, which is 0 rate of change, which means that we're looking at a constant function. Okay, and the function is y equals negative 2. All right, and that's a constant function. And that is it for question number 2. Have a good day.